In this video, we'll be using our TI-84 Plus to construct a least squared regression line. Begin by entering in the data you see here into STAT. Our X variable is study hours, our Y variable is Regents score. That's the score on some test. So I'll go into STAT and list 1. I'm going to enter in the X variables, or the X quantities. 3, 5, 2, 6, 7, 1, 2, 7, 1, 7. In list 2, I'll enter my Y's. 80, 90, 75, 80, 90, 50, 65, 85, 40, 100. Before I draw my least square regression line, I want to look at a scatter plot, and hopefully it will bear some resemblance to the one we see here. We have a strong positive linear association. Go to Y equals, go up to plot 1 and hit enter, and then simply zoom 9. That's the stat zoom. And here you see this scatter plot looks a great deal like this one. Ours looks like it's theirs looks steeper because of this view of the screen. We have this view that's wider horizontally, where theirs is less wide horizontally, but you can note that the points are scattered in a similar fashion. Alright, I want to make my least squared regression line. I will hit stat, then scroll 1 to the right for calculate, and then number 4, linear regression, which we've done previously for finding a line given 2 points. If your screen does not come to here, if it immediately goes back to your home screen, you simply can hit enter. Here I will hit list 1, find list 2, frequency list, leave as the default, store regression equation. I can paste this into Y1 if I wish by hitting vars, yvars, function, and then Y1. This will automatically store it into Y1. It wasn't necessary to do that. We can type it in there by hand, but it'll save a couple of keystrokes. And I hit calculate. We see that our slope is 6.27 approximately, and our y-intercept is 49.8, very close to 50. And if you can imagine drawing in, here's the y-intercept of 50, and this slope would just drive it right on through those points there. Now come to y equals, and our equation's already in there. I hit graph, and there is our trend line, our least squared regression line. In this video, we will be learning how to draw a best fit line without the aid of technology. Here we have a scatter plot of some bivariate data. Our X variable, our explanatory, is the hours of study, and our Y variable is Regents score. That's score on some arbitrary test. And we notice that our data has a positive association. That is, as the number of hours studied increase, the Regents score tend to increase. It's a linear form, and it's a pretty strong association. The points are pretty tight around some trend line that we will soon draw. All right, now our best method of determining a line of best fit is using a calculator and finding the least squared regression line. But in the case that we don't have the use of a calculator, it can often be done by hand. I'm going to introduce what I call the 2-pencil method. First, I'll start with a pencil or a pen and get underneath my data and move my pen or pencil around until I get the general slope of my data. Right now, it's a little too steep, okay? And this is probably not steep enough. Somewhere in between is the best steepness of this data, and I'd suggest that the way my pen is now is closely approximating the general slope of the data. Now I'm simply going to translate my pen up, slide it on up until I get it right in the center of my data. And now this pen is serving as a pretty good trend line. Alright, now I'm going to take my second pencil, and an alternative to using a pencil would be to use a ruler, and specifically a clear ruler. A clear ruler will give you probably the best look that you can get. Now I'm going to sketch this in, and I'm going to do it lightly. That way, if I'm not satisfied with my line, I can redraw. Alright, so here's my trend line, and that looks, I'm fairly satisfied with that. That looks pretty good. Now this point out here that's a little outlier, it probably would pull my trend line down a little bit, but my goal in this case is not to get the exactly squared regression line. It's just to make a decent approximation to one. Now I'm just going to come in, just for the purposes of the video, and darken in my line. Alright, this last step you wouldn't have to do if you were doing this on your own. Okay, and that's my trend line. Now I want to make an equation for that. Well, which points do I choose? First of all, you're not necessarily choosing actual data points on your line. In this case, we have a nice point that is dead solid on the line. I could use that one, but I'm not going to. I'm going to pick 2 points that are on my line that are not data points. I'm going to choose this point here. That appears to be 3 pairs with 70. And I'm going to choose this point here, and that appears to be 8 pairs with 100. Okay, so why did I choose those 2 points? Well, the idea is that I must choose a point on my line. I'm not going to choose one of these points close to my line. I must choose a point on my line, and it's not necessarily a data point. I certainly could have used that point because it appears to be firmly on my line, but I wanted to emphasize that it's not the actual data points we're talking about. It is 2 points on my trend line, my best fit line. Now, using those 2 points, I'm going to use point slope form. Point slope form. The point slope form of a linear equation is the form y minus y1 is equal to m the slope times x minus x1, where x1 and y1 are either of these 2 points. I'm going to choose this point, this 8, 100. So y minus y1 will be 100. M is my slope. Well, remember how we calculate slope. Slope is change in y divided by change in x. Change in y is y2 minus y1, that is subtract 2 y's, x2 minus x1. So in this case, I can use these points. y2 minus y1, I will take 100 minus 70. It doesn't matter which point you call y2 and y1, provided you do it in the same order. Since I did 100 minus 70 in the numerator, I should do 8 minus 3 in the denominator, x2 minus x1. 100 minus 70, 8 minus 3. 100 minus 70 is 30. 8 minus 3 is 5. And 30 divided by 5 is 6. Our slope is 6. That will substitute for m. 6 parentheses x minus, and our x1 we used 100, so the corresponding x value there is 8. Alright, this would be a perfectly legitimate equation of the line. That's an equation in point slope form. Or I can go with my slope intercept form, which is solving for y. So taking my point slope form, Now I'm going to use slope-intercept form. Slope-intercept form. That is, I'm going to solve this equation for y. So distributing my 6 here, I get y minus 100 equals 6x minus 48. 6 times x, 6x, 6 times 8, 48. And now adding 100 to both sides. Y equals 6x. Negative 48 plus 100 is a positive 52. This is slope-intercept form. You can see here that the y-intercept is 52, and you imagine if I extended this line, it very well would strike at 52 over here on the x-axis. Alright, that is how we draw our best fit line without technology.